All right, in this set of videos, we're looking at section 5.4 of our syllabus, and specifically geometry of 3D solids. And we're always looking at right solids. So in your exam, only right-angle trig questions will be set for 3D shapes. So that's what we're going to look at specifically here. So the diagram at the right shows a cuboid. Well, when I see this word cuboid, it means that it's a cube-like figure, but instead of having all sides the same length, I've got some rectangles. So my bottom here is a rectangle, and I can see I've got 9 by 12. But the bottom face, since it's a rectangle, I know there's right angles inside of it. And in fact, all of the faces are rectangles, so I know that I've got right angles inside all of those. So I can see all the dimensions they've given me. First, I want to find the length from E to B. So E to B is the diagonal in this bottom face here. So I'm going to draw a separate triangle. I'm going to call it EAB. And I'm going to make it a right triangle because I know that that's made in a rectangle. So I know that down here, A is a right angle. And so I'm trying to find EAB, so I'm going to put my E up here and my B here. Looking at my picture, A to E, well, that matches with B to F, and that's 9 centimeters. A to B is 12. And so I want to find EB. I'm going to use Pythagorean Theorem. So EB squared equals 9 squared plus 12 squared. So I can put that in my calculator. 9 squared plus 12 squared, and I get 225. So EB then is the square root of 225, which is 15. And I just know that, but of course you could put it in your calculator. So 15 centimeters. All right, the length of EC, well, now here's EC from here to here. So that connects to B, which connects back to my E. So we just found EB is 15. This is a right triangle because it's a cube. So these faces are perpendicular to the face on the bottom. So I'm going to draw myself another triangle. So now I'm going to draw the triangle. EB is my base, and then I'm going to come up to C, and then I'm going to connect those. So here's my E. Oh, goodness. E, B, here's my C. And actually, my C was at the top, and EB is my base. So I've drawn this incorrectly, or I've labeled it incorrectly. So let me go back and fix that. So EB and BC make the right angle. So here's my right angle. So CBE. So I know above EB is 15. So now in this triangle that's inside the picture, so let me put in, so I'm looking at this triangle here. So inside the picture, I've got my right angle at CB. And now 15 is a leg, not the hypotenuse. I know CB, that's the same as GF, so that's going to be 5. So now I can find this again using Pythagorean Theorem. CE squared is 5 squared plus 15 squared. So CE squared is going to be 25 plus 225, that's 250. So then CE is equal to the square root of 250. That one I don't know. 15.8 approximately. Knowing, of course, if I was going to do any calculations, I would do all of them using this whole number. Okay, so that was B. Now C asked me for the angle between EC and the plane. So now I'm looking for this angle inside here. So my plane, ABFE is that bottom rectangle. So I want the angle between EC and my plane, so the two things that draw those. So here's my angle. It's the same as the angle down here. So I could use sine, cosine, or tangent to find it. I'm going to use tangent because I know the 5 and the 15 exactly. This one we just found, that was root 250. So actually I know that exactly as well, but I'm going to go with my 5 and 15. So tan E equals opposite over adjacent. I don't know my angle, so I'm going to use tan inverse of 5 over 15. And then I'm going to get approximately 18.4 degrees. All right, last one. Angle between DB. So let's find DB. DB is up here. And the plane, ABFE. So DB, B connects to A to make myself a right triangle. So now I'm looking on the face of that for this angle down here. So let's draw that out. So we know that we have, oops, 5, and we know we have 12. This was our B. Let's see here. And then we had A and D. This is the angle we want. So again, I'm going to use tan. So tan B is 5 over 12. B is tan inverse of 5 over 12, which is approximately, so now I'm just going to go up and then over right. So 5 over 12, 22.6 degrees.